Hey YouTube, thought I'd make a video here to show you my new test setup. So I went and I got myself a light dimmer, and I printed myself a motor mount here. And this here is a 60 watt AC motor that I salvaged from my old dishwasher. It's the pump motor. But the most important part of the new setup is this piece over here. See this wire over here? It goes to the ground. It's nice and long. It's wrapped in a bunch of layers of electrical tape for the handle. So now I can actually safely discharge everything bit by bit by bit all over the whole machine. Everywhere I want to go, anywhere I want to touch. I call it my magic safety stick. Anyway, so something else as well is, I figure you guys must be getting tired of me making videos of just these stupid little spark gaps here. Like, okay, it's kind of cool or whatever, make a big spark, but I'm interested in these things from an engineering perspective. I want to make a useful generator. So, let's see what we can do here. Let's see if we can make some actual useful power. And see what we got going. Now, I did get a bit of a trade-off here. See, when I moved from my nice hard spot on the floor to up there, I did gain that I don't have to hold on to the thing anymore because it's screwed in place. However, I also gained all of the resonance of this of this bench over here. And something else that I kind of appreciate is when this thing is on the ground and it's running, these lights will be running, but these wires over here, because the plate gets to such a different potential than the ground, it arcs to ground and it sucks up current from the ground, and so these things will be running, and then you'll turn the machine off. And you'll go and discharge it. Like say if you didn't have the magic safety stick, you'd go and discharge it, say by shorting out both sides of the capacitor. And then you'd be like, all right, I'm safe to touch it now. But the thing you didn't realize is this thing was sucking up a bunch of static from the ground the whole time. So even though it's been pumping that charge, if you got this thing sitting on the ground, these lights will be going. And you'll take the magic safety stick and you'll hold it about this far away, and you'll get like a centimeter continuous arc going to the ground without the lights changing brightness. No wonder I was getting shocked every friggin' time I was trying to do anything with the capacitors there. Hey, be careful with these machines. Don't, if you're going to put them on the ground, and you're going to run them close to the ground or anywhere where they can pick up a charge off of anything else, make sure you got yourself a magic safety stick, okay? Tie it to ground, earth ground, a good solid ground, okay? Alright, now that my shop professor who learned the lessons by hurting himself speech is done, check this out. So, turn the speed up a bit here. And the effect is starting up. Check this out. I got my spark gap set over here. The whole purpose of this is to force the machine to produce a high level of voltage. It only produces maximum current when it produces the maximum voltage, because I am relying on the breakdown potential. I popped out. Well, I guess we'll shut that off. I guess that's why it was struggling there. I thought it sounded a little bit funny. I'll fix that after. So now that that it's off, First thing we do, magic safety stick. Touch. Touch both sides. Make sure it's nice and good. Come in here, touch that. Come over here, touch that. This stuff over here. There. All safe now. Alright. So, these, what I'm relying on over here, I finally found enough information to be able to figure out why my machine produces so much current, even though it's only 180 millimeters in diameter on the barrel, and even though my surface area on my charge collectors is less than, it would imply that I'm pushing I'm pushing less current. Anyway, I finally figured out what's going on. So thanks to ChatGPT, and some inquiries and that kind of stuff, because electrostatics is really not my my educational background. I'm an instrumentation and control engineering technician. What I finally figured out is these machines produce such a stupidly high voltage that you actually reach the ionization potential of the metal rods. So a typical machine, like a Benetti machine or a Wimshurst machine, they have these thin, tiny little charge carriers that they spin around this wheel. But then you come over here and you get something like this, where you get like a die rod machine, or you get like this, where I'm using tubes. And all of a sudden, because I'm getting up around 100,000 volts, I'm actually producing the potentials that's necessary to ionize these rods. So that's why when I'm running this machine, it has two steps. It has one step where it's just starting up and the power's kind of okay. But then after it has a bit of a warm-up, because the voltage was able to build in the inductor plates, I start ionizing these rods and I start sucking amps. So, or not amps, but milliamps. Because to produce that light over there, you're looking at like at a good solid number of milliamps there. Well, maybe not milliamps. It's like I think it was, when I did the math, it was like somewhere in the vicinity of you know what? I'm just not going to quote a number because I need to do the math more again. But I'm going to post more videos, because what I want to do right now is I want to see what's the limits. Because I put one light on and I set my spark gap, and I was able to get it to that brightness. And then I stuck the other light and I set my spark gap, and I was able to get 2 times brightness, double the light, which is awesome. And so how many of these can I put in a line? Like if I put enough of them in series, because my machine makes such a stupid amount of voltage, am I gonna? I don't know. Because to me, it seemed like I realize it flies in the face of everything. Like, these machines are stupid. I hate it. I don't know what's going on. That's why I'm doing experiments. Anyway, we'll see you later, YouTube.